Okay, this is section 5, segment 2, and we're continuing the example of the marketing example where a startup company is trying to decide the price that they want to charge on a particular product. But before we calculate that confidence interval, I want to make sure that we understand here what the confidence interval is telling us. We know that under a normal distribution, if we go approximately 2 standard errors away from the mean, or in a z distribution, we go 1.96 standard errors from the mean, we're going to capture 95% of the possible outcomes. And that's what we see here. Now, this is commonly misunderstood. The technically correct interpretation is that if we would have repeated this sampling process 100 times, we would estimate that about 95 of those 100 samples that we draw would fall between the true population would fall between 1.96 standard errors above the mean or the point estimate and 1.96 standard errors below the point estimate. This is not, we're not able to do this because we commonly will only sample one time. And so it's commonly translated into saying we are 95% sure that a particular interval or confidence interval contains the true population mean. So the true population mean in this case is how much is the public willing to pay for this product? Well, we can't say for sure. We know that our sample is 28.6 plus or minus some error. So we would say we're 95% confident that the true price falls somewhere within that interval. To display and give you an idea of what this means, the difference between the technical version and the English interpretation, I have this Java applet that we'll discuss more in class. But what it does is it has a distribution that has a mean of 50, and it grabs a sample from this distribution, knowing that the standard deviation is 10. And it draws a confidence interval around the sample. And then, given that we know what the true population mean is, 50, it counts the number of samples that contain the true population mean. So we start with a sample size of 10, and we sample that, and it samples 100 times. The orange bar represents the 95% confidence interval. The blue bars, so tip to tip, represents the 99% confidence interval. Anywhere that it is red, or white in this case, anywhere that it's red is a sample that does not contain the true population mean. So there's 100 samples here, and we can see that 1, 2, 3, 4, 5. So we get exactly 5 of the 100 in this case that do not contain the population mean. Now, that doesn't always happen because of randomness. In fact, let's clear this and sample again. Now we have 1, 2, 3, 4, 5. Okay, so we still have 5 that don't contain the population mean in the 95% confidence interval. But we actually have 2 samples here that don't contain the population mean in the 99% confidence interval. So we would have expected only 1 of those 100, and we got 2 of those 100. Well, in our marketing example here, we're really only going to sample once. So we can't say with 100% surety that the true population will fall within a certain interval, but we can say with a certain degree of confidence that it will fall. Now the second thing I want you to notice is when our sample size increases, so we can increase this from 10 observations per sample to 20 observations per sample, the confidence interval shrinks. It gets smaller because now I can be more confident with a higher sample size. So let's run this, and we can see that this range of possible answers is tighter. Okay, so we can see this relationship between sample size and error or confidence interval. The higher the sample size, the smaller the confidence interval. We would still say we're 95 or 99% confident that the true mean falls within this range, but now the range is a little bit tighter. So let's finish our marketing example here. So we want to construct this 95% confidence interval for the population mean, or the true mean, although we don't know what it really is. And we enter in our numbers. So our confidence interval is our sample mean plus and minus, because we have to go above and below the point estimate. The z-score for our confidence interval, so if our confidence estimate is 95%, then we would go to a z-table and find a corresponding z-score for a 95% confidence interval. In this case, 95% is 1.96. Our standard deviation is 2.4, and we have 36 observations in our sample. So we would say we are 95% confident that the true population mean falls somewhere between $27.82 and $29.38.